All right, so in this video, we are going to play around a little bit with array lists and this concept of what's called autoboxing and unboxing. So let's start by just making an array list reference. We'll call it my list, and we're not going to specify any type. I'm just going to call the array list constructor. And I get an error at first because I have not imported the actual file that explains what an array list is. So let's fix our imports. It'll pull that up, and now I have an array list that I can add things to. Now, the interesting thing here is I can add anything to it at this point. So let's add a, oops, hold on a second. If my computer isn't freeze, it is, I can add anything to it. Let's add the number 3. Let's add the word cat. So I'm adding a string to this list. And let's also add, how about a scanner for whatever reason. So we'll do a new scanner system.in. All right, and that'll probably require an import as well. So we'll do that. All right, so by default, array lists are meant to hold objects. And because I have not specified a type, it's allowing me to put any object in here. And I should be able to print these out. So let's do this for each object O in my list. We'll just print it, system.out.print line. O. Okay, so just as a quick test to make sure these things actually went into the list, we'll run it. And there we go, 3 cat, and then the scanner. I was able to add all 3 things. But really, array lists are meant to have a type specified. And one of the reasons for that is, say I wanted to get something out of my list. So for example, say I wanted to take in the string x equals my list dot get the first thing in the list, which is a cat. Remember the 0th thing, first thing, and then second thing. Even though that is a string, it's going to give me a problem. So now I'd be forced to cast in order to have it work out okay. But if I were to do this instead, if I were to specify that the only thing going into my list were strings, I wouldn't need to do this cast, but I also couldn't add the scanner or add the number 3. So we're going to specify types here, but what we're going to do is let's specify not as strings, but as integers. All right, and that means let's get rid of these 2 lines. We'll get rid of this line as well. So now I have my list at 3, and because integers are objects, I can still use this enhanced for loop down here. Let's run it, make sure it works. I should only have the number 3 in there, and it does work. Now, the interesting thing here, though, is that 3 isn't really an integer. 3 is a primitive type. So let me show you exactly what I mean by that. We can have int x equals 7, and I can also have integer, so integer class y equals a new integer with value 9, let's say. Now, x and y are storing, well, make them the same number too, even. They're storing the same values, but they're storing it 2 different ways. X is a primitive type, y is a class, or a reference to a integer type. Now, the interesting thing here, though, is even though my list is supposed to only store integers, I can add both x and I can add y. All right. And let's just test this and run it, make sure I should see 399 in my output. When, of course, my program compiles and runs, there we go, 399. So if I'm specifying that only integers can be put into my list, how come I'm allowed to add x, which is not an integer, it's an int? Now I can add 3, which is not an integer, it's an int. Well, the answer comes from this concept of what is called autoboxing. So autoboxing is when a method, so in this case add, that expects an integer type, sees its corresponding primitive type, it automatically converts it into an integer object. So, for example, if I wanted to take integer y and actually say, instead of making it equal to a new integer 9, I could actually say get, whoops, my list dot get the thing in position 0. And I'm also not going to get an error because my list is full of integer objects. And even though number 3 or the value 3 was passed in to my list, it got converted to an integer type. So now when I say to take it out, y is a reference to it. And now I can run it again, and now I should get a 393 in my output. 393. Since I'm now creating another version of integer and adding that again to my list. So autoboxing is when a primitive type is converted to its corresponding wrapper class, and then unboxing is when a reference to a wrapper class or a reference to a value stored in a wrapper class is automatically converted into its primitive type. So I'll show you how that might work up above. Suppose I wrote a method, public static void test unbox. Oops. And I'm going to say take in an int x, and we'll say out.println unboxed and x. So we're only going to, oops, sorry, I accidentally hit page down. So this method just says take in an int and print it. And I'm going to, just for clarity's sake, I'm going to uncomment these print statements down here so we don't get confused at all. So we're going to do 2 quick tests of this. So first thing is I'm going to say test unbox with just the value x. And since value x is an int, I should get no compiler error, I should get no runtime error, I should run it and just say unboxed 9. Which is a little bit silly because we're not actually doing any unboxing now. I've passed in a primitive type, I expected a primitive type, I printed a primitive type. But let's do this now. Let's take, instead of an int, let's take an integer y, which equals a new integer, number 10. And let's see what happens when I pass y here. Well, I don't get an error. Even though I was expecting an int type, the Java virtual machine looks at this and says, well, you know, an integer is really just a wrapper class for ints. So I'm going to pass this integer in and just treat it like an int. I'm going to unbox it for the programmer to save him a little bit of time. So now when I run it, I should see the number 10 pop up without any problem. So in that case, it was successfully unboxed. Now, what if I did this? What if I had two methods? So I'm going to overload these methods by having 2 of the exact same method, but one of them I'm going to write integer, and I'll have unboxed and it says not unboxed. So now I have a version of this method where I can pass in an int and it'll say unboxed, or if I pass in an integer, it'll say not unboxed. Well, let's try it first with x. So remember, x is an int. It's a primitive type. If I run it, I expect this method to get called, the unboxed method. And there it goes. And now when I say test unboxed with y and try running it, this time I get not unboxed. So because these methods were overloaded, the type of y is going to select which of the methods to run. And in this case, because there was an overloading with both a primitive type and its wrapper class, it selected the version that uses the wrapper class and did not unbox y. So in that case, y remained an integer type. However, when there was no option to unbox it, when there's no option for that method, y gets unboxed and turned into an int. So this is an important aspect for array lists in particular, because you cannot make array lists store primitive types. It won't even let me. I have to have a reference. So this process of unboxing and autoboxing is very relevant for array lists, because even though you cannot make an array list of primitive types, you do have the capacity to put primitive types into an array list. So hopefully that cleared up what autoboxing and unboxing is, and I hope you enjoyed the video. Bye now.